Hello, Soundies. Welcome to our Sound for Video session. Today's the 4th of September, 2022. It's good to have you all here. For those that are here live, would love it if you could have a vote in our poll here, and we'll talk about that in just a moment here. Okay, we'll pop over to our agenda now and take a look at what we have going for today. First up, had a number of questions. We have had videos on our channel talking briefly about hiding lavaliers, but if you are interested in diving in and learning from a production sound mixer how to hide lavalier microphones, my friend Thomas Popp, who has a website and a online course school with a bunch of courses, has a hiding lavaliers masterclass. And if you're interested in that, we've got a link in the description down below. He gave us a coupon code. That's also down there if you're interested. Hope you find that useful if that's of interest to you. Now, for today's topic, we have a poll, and it looks like the votes are coming in. Thanks, everybody, for your votes there. We'll use that as part of our discussion, but the main topic for today is talking about unbalanced and balanced audio, the differences between them, and how to interconnect between them. So, for example, if you have a device with balanced outputs and you need to get that audio into a device with unbalanced inputs, how do you make that conversion? How do you make that work? And also vice versa. If you have something with an unbalanced output and you need to get it over into something with a balanced input, how do you do that? So we will cover that here. In fact, we'll do that right now. So let's go ahead and pop over to the full screen here. All right. Balanced and unbalanced audio connections. So we've got our poll going here, and we have 16 votes. And I have to confess, it's a little bit of a trick question. The good news is that everyone that has voted has the correct answer. And Christopher Wichura, your comment actually, if you want to put Christopher's item up there real quick. Danny's going to pull that up. So in any case, it really depends on a lot of things. So Christopher says that the poll question depends on cable length. And yes, that's absolutely one of the things that's most important is the length of the cable that you're using. Let me just boil it down this way. I think the most important consideration is that balanced audio can handle noise and reject noise. And that's going to be RF noise, radio frequency noise, anything that it picks up along the length of the cable, better than unbalanced audio. That's the core thing that you need to understand about balanced versus unbalanced. It isn't as if unbalanced audio cables intrinsically sound worse than balanced. After all, it is copper cabling that has a voltage going through it, some current flowing through it. And that's all it is. And so if you have a high quality unbalanced cable and you're not doing a long cable run and you manage to keep any sources of external noise away from it in the form of electromagnetic fields or radio frequency, then an unbalanced cable and an interconnect using an unbalanced cable can sound just as good as a balanced connection. So that's where this is a little bit of a trick question. So thanks everyone for taking the poll, and everyone that took it is basically right, because you can argue it both ways. So it isn't really necessarily balanced sounds better than unbalanced. It is that balanced is more immune to RF and electromagnetic interference than unbalanced cables are. Let's talk about what that means in practical terms. We actually already answered that question, so we're going to jump right ahead here. We have a little diagram. Emma put this together. We're refining this over time. But on the top, we have represented an unbalanced cable, and both of these represent a mono cable, just one channel of audio. And then on the bottom, we have one that represents a mono balanced signal. And the first thing you'll notice is that an unbalanced cable has the two black lines represent wires within the cable. So in essence, an unbalanced cable will have two wires. And on one wire, you'll have the audio signal, and on the second wire, you'll have ground. Okay, and then unbalanced, you have three wires. That's, for example, if you take a look at an XLR connector, and if we switch on over to the overhead here, Danny, really quickly. So you're all familiar with an XLR connector. Here's an XLR female connector. You can see it has three different connection points, sockets, if you will. and that is because it has 3 cables running through the inside of it. So that is what a balanced cable, balanced mono cable will have. Okay, switching back over to our diagram here. In the case of the balanced audio, though, it's doing something different. It has the signal on two of the wires, and then ground on the third wire. But what's interesting is that the audio is actually the same audio on both of these. So here, for example, is the audio. Now notice on that, the audio on the second wire here, I'm gonna clear that. Let's actually look at a different one here. Let's go over here. So on here versus here. So it's the same audio, but the polarity is inverted. Okay, so it's the exact same audio, but the polarity is inverted. And the reason for that is that's the trick, that's the magic that makes this more immune to picking up noise. So the lighter gray waveform that you see there is the noise, and that actually will get onto both of those wires. The noise will be on both wires, but it will be the same on both wires. And that's how the inverted signal on the 2 wires, the inverted signal that you want, the audio that you want, is able to we're able to remove that noise, because at the end here, once you get to the input, it can take all of this. And if it takes just a signal and the signal in positive polarity and negative polarity and sums them together, that actually comes out to 0. Okay, so if you sum this right here and this right here, that actually comes out to the 0 line, the minus infinity line, if you're looking at a waveform. But what remains is the noise. And so it can then take that noise and subtract it from the overall signal. So it can take this part here, this is the noise here, and that would actually be on both of those wires. It can actually subtract that because that's what's left once you sum these 2 wires. And it can subtract that, and then it can just take this one right here, subtract all the noise, and then you end up with this very clean signal here at the end, at least in theory. You can still pick up noise on a balanced cable. I don't want to suggest that you cannot, but you can come up with a much cleaner signal. Whereas in the case of the unbalanced up here, you'll notice there's nothing that is going to remove that noise, really. You just have to, rely on shielding of the cable, keeping the cable away from electromagnetic and potential radio frequency interference, keep the cable short. You have to keep in mind a cable is essentially a big antenna. So that's why you want to keep it a little bit on the shorter side if you're using an unbalanced connection. Generally 15 feet or shorter is what you want to stick to. If you do that and you stay away from sources of electromagnetic interference, then you can generally get a pretty good signal through it without picking up a lot of noise. But if you're going to run something longer, that is where the balance signal is going to do a lot better for you. So just to kind of, again, summarize this part down here, let me just clear all that. This part down here, so we're taking the audio, again, that's inverted, and summing it along with all the noise that's been introduced, and that noise is going to be on both cables. Once you sum it down, the only thing that'll be left is the noise. And then what the input does is it essentially takes just one of these, subtracts the noise, and you get this clean audio. So that's in essence, at a very, very high level, how balanced audio works. All right, and then to put that into words, this is from the Sound Reinforcement Handbook. Let me just show you that. Danny, if we could go back to the main camera for just a second here. So Yamaha sponsored a book called the Sound Reinforcement Handbook. It's kind of like the ultimate engineering guide for front of house engineers, but a lot of great information in here. Do recommend it. It's pretty dense though, just be aware of that. So you've got a lot of, you'll learn some things about electronics in here as well. Things like, you've got some electronic diagrams, block diagrams, lots of great information. Very, very good source of information. So let's go back to this and get the quote from there. This is their description of a balanced interconnect here, sending balanced audio over a balanced connection. The 2 wires of the balanced cable carry the same signal, but each wire is opposite in signal polarity to the other. Should any electrostatic interference or noise cut across a balanced cable, the noise voltage will appear equally with the same polarity on both signal carrying wires. The noise is therefore canceled or rejected by the balanced input circuit. So just a quick run through of how that works. Now, achieving a balanced signal from different pieces of gear can be done inside of the gear in a variety of different ways. It can use transformers. It can use, and we talked about transformers a few weeks ago. It can use what are called differential amps, and it can also use integrated circuits. And each of them have their kind of benefits and costs, if you will. I think generally a lot of people assume that transformers are going to change the sound a bit more than perhaps an integrated circuit will. And that might be true more often than not, but it's not universally true. You can have there are very good transformers out there these days that can also be very transparent as well. So in any case, those are the different ways. So for example, in a camera that has a balanced input, so for example, that's going to be a cinema camera or maybe an electronic news gathering camera, those will usually have balanced inputs, and they'll probably in most cases using integrated circuits to achieve that balanced input on those cameras. Whereas transformers are the kinds of things you'll find more likely in DI boxes, vintage gear, vintage style gear, things like Neve, Rupert Neve things, and all the stuff that goes along with that. So that's one thing to keep in mind. There's another thing to keep in mind as well, and that is that line levels can be different between consumer level gear and pro level gear as well. And this is often associated with the same thing. It's a separate dimension, if you will. But typically when you have a balanced output, it's usually at plus 4 dBu, which is a slightly different standard than minus 10 dBV, which is the consumer line level output. So if you're talking about a phone, that's generally going to have a minus 10 dBV output, whereas a mixer is going to have a plus 4 dBu output. The only thing you need to keep in mind here is that if, for example, you are sending audio from an unbalanced piece of gear into a balanced input by doing a conversion that we're going to talk about here in just a minute, you will also have to account for the fact that that consumer line level output is weaker than the balanced line input is expecting. So you're going to have to do some amplification at some point in that signal chain as well. So just something important to keep in mind there. Okay, let's go over to our overhead camera and take a look at what we've got here. I want to just demonstrate some of this before we go farther in the discussion. I have a mixer here, so this has balanced outputs right here. And the first thing I want to do actually is I want to disconnect those. I want to show you, well, actually, let me describe what we're trying to do here. So I've got this mixer with balanced outputs, and I'm using a switcher today for our live stream called the ATEM Mini Extreme ISO. The ATEM has unbalanced 3.5 millimeter stereo inputs. You can switch them to line level, but they are unbalanced. And so how do I get the balanced audio out of this mixer into the ATEM? And I have a few different options here. And first I'm going to show you the wrong way to do it and the way we did it 2 weeks ago. I'm going to go ahead and pull these cables out. We're going to put those back in to demonstrate how to do it in just a moment here. But the first thing I have is this cable right here. And this is a cable that I used 2 weeks ago. This cable was misrepresented when I purchased it. It has two XLR female output or female connectors so that I can connect those to the outputs on a mixer. And then on the other side, it has a 3.5 millimeter TRS plug. And what it's supposed to do is it's supposed to take a balanced signal here and a balanced signal here and just take the first audio line from each of those and send them to an unbalanced connect here where you have the audio on one from the left channel, audio from the right channel on the other, and then ground on the third one. So balanced to unbalanced. But in fact, it doesn't do that. It's wired incorrectly. So that's why we had that issue a couple of weeks ago. And what I'm going to do is go ahead and demonstrate what that sounds like so you can hear what happens when what's actually happening here is it sounds like it's taking the two audio lines from one of the connectors and putting those on left and right here and then ground on the third one. And what that means is that the audio you're getting into the ATEM is actually inverse polarity. So let's go ahead and I'm going to bring a mic up here. So if we go to our main camera here again, So I've got this microphone here connected to the little mixer that we were showing you. And now I have that cable connected, so I'm going to switch over so that you can hear what this sounds like. I am excited to demonstrate this. Here we go. Okay, now I am on this microphone coming into the Mackie 802 VLZ4, the little mixer we had here. And that's using that cable into the A10 Mini. And I'm curious how it sounds. We should have some inverted polarity there. So what'll happen is especially if you're here using headphones, it'll start to sound a little tinny. And let's see here if I'm just going to make some changes onto this. Yeah, I think we're good there. So let's go ahead and I'm going to switch back to my regular microphone. Let us know in the chat how that sounds. I didn't talk very much. Danny said keep talking, so I'll go ahead and keep talking. I'm going to move just back from the microphone, just a touch. Ooh, lots of mouth noise. This is a very bright microphone, and so this is what you can hear when we're going through the mixer to a cable that should be converting from balanced to unbalanced, but is not. And there are different ways to do that. You can do it by basically just using one of the audio lines from a balanced output and just sending that one into the balanced input. So with an ATEM, for example, if we go over to the Mac here.
You're getting comments now.
I'm getting okay, we're hearing it, okay. All right. Well, in any case, I'm going to talk about how you can actually solve that problem to some extent here. And let me just demonstrate it now. In the ATEM, you have a special feature, which is actually really quite nice. And that if I come into the little gear down here, and I have that audio coming into mic 2, I'm going to split it. So split audio into separate mono channels. Okay. Now, this is me where I'm taking just one of the inputs from that stereo input and just using that. And that sounds quite different, you'll notice. So that's the difference between taking inverted polarity audio in the left and right channels and just using basically the left channel, but sending that left channel to both left and right. Hopefully that makes sense. Certainly it sounds different, and you can hear the difference distinctly. Okay, let me switch back to my main mic here. Okay, back on the main mic. All right, let's go back over to the overhead here. Okay, so that's one way you can solve that problem. It's not every time that you have an ATEM Mini, so you can't always do that little trick where you essentially just take one of the audio feeds from a balanced output, so that's not always an option. It's a neat little trick with the ATEM, but there are other options, and let me just show you one of them here. This is kind of like maybe more of a Cadillac option, I guess, a nicer option. This is the Art CleanBox Pro. And this is actually a pretty neat box. It's actually designed to take a balanced input and convert it to unbalanced, or vice versa. It can take an unbalanced input on the other side here. Let's see. Yeah, unbalanced input. You could do it via RCA or 3.5 millimeter down here. And convert that to balanced. So that's another option for you, and we'll come back and get you a demonstration of that one in just a little bit here. A really common way, if you're going from unbalanced to balanced, is to use a DI box. And a DI box is a DI, there's some, I guess, disagreement about what DI stands for. But in my experience, I've heard people either refer to it as a direct box, so DI evidently standing for direct, or it could also stand for direct injection. In any case, what it does is this one, for example, the PCDI made by a company called Whirlwind. On one side, you have your inputs, and these are all unbalanced inputs. You can go on RCA, 3.5 millimeter stereo, or 2 1/4-inch mono inputs, all unbalanced, to 2 balanced outputs. So this is a stereo DI. A lot of DIs are just mono. And a lot of times you'll see DIs on stage for live shows where they will connect an instrument into the DI. So the instrument will have an output of that'll be just a mono, in some cases stereo, but usually mono, unbalanced, and then it will convert it to balance so they can get that signal all the way to the mixing board. Remember, we talked about how unbalanced cables, you generally shouldn't run them more than about 15 feet, and that's exactly why you would use a DI box on stage, is to get that unbalanced signal from the instrument, convert it to balanced, and then send it to the mixer from there. Because the mixer, typically is some tens of feet away or multiple meters away from the stage, and so that's the idea here. But the interesting thing is that you can also use a DI in reverse. So usually a DI is basically just a transformer, but you can actually feed audio into the output of a DI if you have a balanced output that you need to get into an unbalanced piece of gear, and then run the unbalanced, what is normally the input, into the other piece of gear. And we'll demonstrate that here. So the trick with this is that you have to have the right cable. So you'll notice that the output is male XLR on the DI box, and the output on the mixer is also male XLR. So you either have to have a female to female XLR cable, which is a little bit unusual. It can be done, and you can have one of those custom made for you. You can probably order them places as well. In this case, I have a 1/4-inch TRS to female XLR, and it so happens that I have a balanced balanced 1/4-inch TRS output here, so I can connect this here and then connect this into one of the outputs. So now I'm feeding the output from the mixing board backwards into the DI. And then let's just get a 3.5 millimeter TRS connector that's going to go into our ATEM Mini. Okay, we have that now. All right, let's switch over to that and see how that sounds. So let's go back up to our main camera here. What I'm going to do is let's do that. Put on our headphones just so I can see what it sounds like. And muting this mic and unmuting this microphone. Okay, can you hear me okay? It's a little quiet, and that's actually because I think this is also attenuating the signal to some extent. I can boost it a little bit here. So just to get it kind of equal level there, now it's coming up better. So on the ATEM, if you go over to the Mac really quick, Danny, what I did is I just boosted it here. You could use the fader, or we could use the gain here. So I can get additional 6 dB of gain, or I can actually use a little bit more here on the fader. In any case, you can see that that's where the whole idea of +4 dBu and -10 dBV comes into account here. So you may have to boost things up a little bit if you're going from balanced output to an unbalanced input, if you're using something like a DI. So that's how a DI works. That is an option. Not a horrible option, but you do have to have the right cables to make it work. So just something to keep in mind there. Okay, I'm going to go ahead and mute this and back on my main mic. Okay, let's switch back over to the overhead. All right, next up, let me talk about the clean box a little bit more here. And this is a kind of a funny device in some respects. It's typically you have on these kind of boxes, you have all the inputs on one side and the outputs on the other side. But this one's a little bit unusual. All the inputs are here, except for the 3.5 millimeter input, which is here. I'm not sure why. And then all the rest of this is output. So the 3.5 millimeter unbalanced output, RCA unbalanced outputs, and XLR balanced outputs. In addition to that, you also have an amplifier here, so you can amplify the signal a little bit. So that's useful, again, for those conversions between +4 dBu and -10 dBV. So in this case, we're going to go ahead and feed the mixer output into the CleanBox Pro, and then on the back, I'm going to connect this 3.5 millimeter output to the unbalanced output right there, just like that. Let's go ahead and put this back up here. Now I've got a mess of cables. Hopefully we haven't got any unbalanced cables near power cables or anything else that could introduce any noise or anything like that. But let's do this. I'm going to...
Do you still need the other DI connected?
It doesn't matter if the other DI is connected at this point. Okay. So I've got the balanced outputs connected to... I'm going to just unplug this just to make it clearer what's happening here. Unbalanced stereo outputs into the CleanBox Pro, which is now sitting back here. And then out of the CleanBox Pro, a 3.5 millimeter unbalanced connection into the ATEM Mini. Let's switch over and see how that sounds. So we'll go back to the Mac. First, I'll mute my main mic and then unmute the other mic. Now this level is coming through quite a bit hotter, and I have that amplification. I can turn that down a touch. Actually, let's get this back to 0-ish. And there. Okay, there we go. That's about where we wanted to be. So this is what you're hearing through the Art CleanBox Pro, converting a balanced set of outputs from a mixer to an unbalanced stereo 3.5 millimeter cable that goes into the ATEM Mini. So that's how you can get audio out of a balanced output and into an unbalanced input, and vice versa. So let's go to the chat and see what we have going in the chat here. That's our mini lesson. Daniel James Van Delsum says, that sounds fine too.
So these two latter ones people like.
Ah, the last two people like the DI and the Art CleanBox Pro. Good, yeah. Those are going to be the better solutions. They're more expensive. The Art CleanBox Pro is about $90 US. The PC DI, which is a stereo DI, was actually like $170 US. So. Yes, so Mark asks a good question. So the DI doesn't require power, but the CleanBox requires power. So yes, the DI does not require power. It is just a transformer. But what you don't get with the DI is that it doesn't adapt, it doesn't have an amplifier to account for the differences in levels between the balanced plus 4 dBu output and the minus 10 dBV input. So that's what the Art box, or the Art, the name of that thing is going to drive me crazy. The CleanBox Pro has is it allows you to adapt. You have essentially an amplifier where you can change the level. So yes, it requires power, whereas the DI doesn't. And the DI also requires a special cable, as opposed to a standard set of cables.
This refers to the Roland, and there were other comments to that same effect.
Okay, yes. So this is again. Yeah, so sound is good but low, and that's the thing you're going to have to take care of here is you're going to have to reamplify the signal potentially somewhere in the signal chain. So downstream probably. Oh, I'm sorry, I just hit the mic. I left that mic on. We're going to switch back to my main mic here. Okay, back on the main mic. Mike says, the Art DTI is super flexible for balanced unbalanced conversion and connectivity. So it sounds like the Art DTI is another product. Let me see if I can pull that up here on the Mac here. So we're over at Art. Let's see if I can find their products here. Is it maybe, it might be under DIs. In any case, if you have, looks like they've got a whole bunch of them. A whole bunch of different options. But in any case, yeah, that could be another product that does a very similar thing there. So thanks for sharing.
Okay, we're going to go all
Mike.
the way back to the diagram.
Okay, we're going back to the diagram. Let's go back to our main cam here. Kershaw, so I should disagree. The explanation of balance being shown is a very common erroneous belief. Balance will actually work quite satisfactorily without a ground. Yes, you can have a floating ground as well. So yes, we spoke at a very high level. Thank you, Mike. We didn't get into the details. There are lots of ways to approach this. And yes, for Shoji, yes, on your diagram, you may want to add the noise signal to the other in phase line. Yes, that's a work in progress. We'll do that as well. Question, is using the HDMI audio pipeline a way around the 3.5 millimeter audio connection? And the answer is yes. If you, for example, what you're hearing right now, I have this going into a channel strip that does the amplification and a little bit of compression, and then it sends it to the camera, which then combines it with the video and sends it via HDMI into the ATEM Mini. So yes, you can completely bypass all of this other stuff. But if you're trying to get a mixer, you could run a mixer into your camera, and then that'll be carried forward via HDMI. There are lots and lots of ways to do this. So lots of things to consider there, lots of options. Thanks, Charles. Matt, FYI, they have released a Kindle version of the Sound Reinforcement Handbook, so it is nice to have in your pocket to refer to if needed. Oh, great. Very good. So you have an electronic version as well, if you're interested in that. It's a big book, if you want to keep it small. Hi, Yanti. How does a adapter work? 3-pin XLR to 2-pin 6.3 millimeter adapter work? I know there are more advanced converters, but this is only a dumb adapter with no electronics inside. Yeah, it depends on how it's wired. So I think in general what it's doing is it is taking, let's go to the, actually I can hold this up. Here is a 2-pole TS connector, 1/4 inch or 6.3 millimeter, if you will. Same thing. It depends on how it's wired. So typically, if that if that's a product that's to get from an unbalanced output to a balanced output to an unbalanced input, in essence, what it's doing is it's taking just one of those audio channels or audio conductors from the 3-pin XLR and wiring it to the tip of the TS here. So in essence, it just turns the whole cable into an unbalanced cable is what it does. So hopefully that answers the question.
Okay, the next set of comments pertains to...
Wait. Let's get you on a microphone. Here we're going to get Danny on a microphone. Unmuting. Okay.
Hi, everyone. Okay, the next set of comments refers to the first demo that you did with the out-of-phase audio.
Okay. Wow, moved to the right monitor. Okay, strange sound indeed. Definitely strange sound. Wow, that's a very noticeable degradation. Indeed. Christopher says, the other mic sounds very different, making subtle changes harder to hear. The bass is very pronounced on the RE compared to your Icon, for example. Okay, so actually this is an Ethos and an SV33, but I understand what you're saying. They are very different sounding microphones. Yes, I didn't want to spend the... Audio Buff says my bathroom sounds better than this. Yeah, probably so. But if I could have two of the same microphone, Christopher, you're right. That would be the best way to do it. Another way to do it would be to actually disconnect and reconnect. And the way things are set up here, that's not very feasible. But yes, you make a valid point. The right signal is louder than the left. Yes, that is a little funky thing with, if we go to the, let's go to the Mac here. You'll notice here as I talk, notice these signals right here. They're kind of hard to see, but one is louder than the other just slightly. It's because the pan control, the ident on the pan control is just a tiny bit off. It's one of those funny things about this particular copy of the mixer. If I tweak it here just a little bit, now they're exactly the same. I don't know if that was what you're referring to, but yeah, the pan potentiometer is just a little bit off. So, good eye. Tim says, audio is completely canceled out on my cell phone, hearing nothing. That is a great point, Tim. Thank you so much for bringing that up. I'm going to guess that you're using an Android phone. A few Android phones, not all of them, but some of them actually sum the left and right audio before they send it out of the speaker. And when they do that, they cancel out each other exactly when we were using the phase inverted audio sample earlier on, when I used this bad cable. I'm going to call it the bad cable, that was not converting to unbalanced, but actually just sending all three poles of the balanced connection. So that's exactly what the problem will be if you're not careful and you don't work through sending the right type of audio from one piece of gear to another. So great example. Thanks for that, Tim. I have now abandoned buying adapters because of the incorrect wiring so often encountered. I now solder them myself. That's a good that's a good strategy, Mike. I completely agree. I learned my lesson on that one. Fortunately, it wasn't a big outlay of money, but it was embarrassing. And I'm not going to just blame the cable. I should have done the testing ahead of time to know that. But in any case, Good point. Mark, another great source of in-depth audio information is Handbook for Sound Engineers, 5th edition by Glenn Ballou. Very good. Thank you, Mark. We'll have to check that. Hante. Yanti.
Oh,
Oh, John. Jan. Like John. T. Like nickname for Jonas.
you can study that.
I'll have to study that. John T. Okay. I use a MixPre 6, but only have a 3.5 millimeter out. I want to connect it to a Blackmagic Pocket 6K Pro that has 2 XLR input. A big DI box is very big for handheld. Can I use a 3.5 millimeter to 2 XLR? No, no, and actually the Pocket 6, doesn't the Pocket 6K Pro, does it not have a 3.5 millimeter input? Why would you not just use that? Since they're going to be right next to each other, I could be wrong. I don't know about the Pro. I only had the non-Pro version. So let's go to Blackmagic Design. To the products, to the cameras, to the 6K Pro. Sorry for all the motion here. I don't know if do we have the specs somewhere? Tech specs, here we go. Let's go for the Pro, whoops, 6K Pro. Connections. Yes, no, that's an output. Analog, you have too many XLR and a 3.5. You want to use this 3.5 millimeter stereo input is what you'll want to do.
Here's a clarification.
Oh, you want to use a 3. Well, no, I don't. You're going to have to make a choice. You get one or the other. So that's just a limitation of the camera and the connectors that it has. So you could...
Oh, sorry.
Well, you could also... There are some adapters. Could there... I'm going to have to think about that. If anyone in the chat knows something right off the top of your head that could work, let our friend know. Why are you using timecode and sending audio? Why are you doing both?
I have a comment up there.
Yeah, no, the Blackmagic Pocket Cinema camera has 3.5 millimeter for timecode. Well, it's a 3.5 millimeter stereo input. It can be used for timecode or audio, not both at the same time, of course. But it says all audio inputs can be used for timecode inputs. So maybe you could get an XLR in to one of those you send the timecode in via one of the XLR and then use the 3.5 millimeter for audio. That's an option potentially, it looks like, based on the specs. So that's something to consider as well as an option. Just to try and avoid, I understand having a big DI box doesn't sound practical if you're trying to handhold it. So hopefully that helps. Okay. Could you explain the difference with star quad cables? No, I don't really understand that, to be honest. I have to confess, I'd rather be honest with you than tell you the wrong thing. But they're evidently supposed to be more immune to radio frequency and electromagnetic interference than standard cables, and I don't really understand exactly how they achieve that. Okay.
Let's move on to your
question and answer time.
We'll come back to some others.
We'll come back to some more questions in just a bit here. All right, we had a few questions that were sent in ahead of time. First is from Roland, and this is his question is actually quite similar to Yanti's. I have a MixPre 6.2, which I've been successfully using as a preamp and denoiser for an MKH50, and then feeding the line out from the MixPre into a Midas XR18 mixer for effects and redistribution. It works quite well for this application. When connecting the same MixPre into the UAD Apollo Twin-X quad interface, which is properly set to line-in mode, the audio from the MixPre sounds tinny and thin. This is true for both inputs on the Apollo using different cables, etc. If I connect the MKH50 directly to the Apollo and use its built-in preamp, it sounds great. Any idea which would cause this seeming incompatibility between the MixPre and the UAD? I would rather use the MixPre as the preamp because this makes it easy to make both a dry and a wet via aux input back from the Apollo recording in hardware. Is it an impedance mismatch or similar type of problem? It is actually just a problem of sending unbalanced audio, stereo output, into a balanced input. So you just need to use a DI, is what it sounds like. So using a DI would solve that problem for you. I'm 90-some percent, I'm going to say 99% sure that that would solve the problem for you. So that's what I would give a try to, Roland. The Apollo has a balanced line level input, so that's why you're experiencing that there. So in essence, you're sending a stereo unbalanced connection, and the input is interpreting the two audio channels as the same thing but polarity inversed, and so it's trying to sum them, and that's why you get that thin, tinny sound. Okay, next up from Kevin, is there a way I can connect the Sennheiser MKE400 to a line input of my Behringer Xenix QX1202 USB or Behringer Xenix Q502 USB? Those are mixing boards, I assume. I've tried adapting from quarter-inch to TRS, and that does not work. Well, there are two things you have to consider here. This is not just an issue of line or balanced versus unbalanced. This is actually line versus mic level. So the Sennheiser MKE400, as I understand, if I'm thinking of the right microphone, has a 3.5 millimeter TRS output. And it's a microphone level output. So you need to get that into the Behringer, which is expecting a balanced input. So what you need to do is probably use a device, an adapter like a Rode VXLR Plus or a Rode VXLR Pro. There are other companies that make those as well. But in essence, what that's going to do is the MKE400 also needs a power source. It needs plug-in power. Your mixers can only supply, if I am right about those mixers, they can only supply phantom power, which is 48 volts usually, versus plug-in power, which is 3 to 5 volts. Pretty big difference in terms of electrical potential. So you don't want to feed phantom power to your MKE400. So that's what the VXLR Plus and the VXLR Pro will take care of for you. In fact, I would suggest the VXLR Pro if you can, because that will actually convert the audio from the MKE400 to a balanced connection, which is what your Xenix is expecting. And it will also take the 48 volt phantom power from the mixer and convert that to 3 to 5 volts plug-in power, so you won't damage your microphone. So VXLR Pro or VXLR Plus should be your solution there, Kevin. Okay, that's everything that we had submitted ahead of time. So let's go back to the chat here, and we've got a little over 15 minutes. I'm going to take a sip of water here because I've been talking a lot, and I'm going to mute my mic before I do that so you don't have to hear slurping. Okay, what do we got there, Danny? Christopher, mixers often allow both balanced and unbalanced on the same input if just the positive pin is connected. Apollo might not have an input circuit that can deal with no negative. That's my suspicion on the Apollo. And good to know. Thank you for that, Christopher. It's easy to get confused about balanced audio on jack connectors. The same connector is used for both balanced mono and unbalanced stereo. They are not compatible. Yes, you'll want to read your documentation or read the face of the mixer, which will generally tell you. And in fact, if we go to the overhead here, you can't necessarily see it, but this balanced, unbalanced, left and right main outputs here. So this can be balanced or unbalanced. How do you switch it from balanced to unbalanced? If you are sending it unbalanced, you'll use a TS quarter-inch connector like this. And if you want it to be balanced, you'll use a TRS, a 3-pole quarter-inch plug like that one. That's how you switch on this particular one. Thank you, Mike. Thank you. What I admire about your channel is that you are serious and don't give answers just to give them. Thank you. I also try to be honest and say I don't know the answer when I don't know the answer so that I don't mislead people. Never intentionally, at least. So thank you for that.
Here's a clarification.
Scratch audio for editor. Okay, that makes sense. But yeah, I would try to see if you can get the See if you can get an adapter cable for your timecode input to go into one of the XLR inputs, and then you can use the 3.5 millimeter for audio. Oh, birthday cake. I did make a birthday cake. It was delicious. There was a moment there where we thought we were in trouble. I thought I was in trouble because I messed up the frosting, but it turns out it didn't need frosting because it was a dark chocolate cake with cherry preserves on the top and then some additional cherries on top of that. It was just, it was good. Very good. I hope you have a birthday again really soon so we can have that cake again. All right, just tested. Using a splitter, you can use an external mic and timecode into the 6K Pro. There you go. Splitter will do the job. You have to switch the audio inputs because one of the inputs will have timecode going into it. Very cool. Great to know. Watch for crosstalk though. But it's just scratch audio. It shouldn't be a problem. Can't use a splitter to send the scratch to one channel and timecode to another. There's an option there, but again, be careful of crosstalk, especially if you're sending a line level timecode on one conductor and then audio on the other. That if it's not really well shielded, there's a good chance you're going to get crosstalk there. And what I mean by that is that the timecode will be, you'll hear the timecode in the vocal channel with the dialogue, assuming it's dialogue. All right, just came from the F1 GP Zandvoort, and you'll have to excuse. I don't know any. I have a lot of Dutch ancestry, but I don't actually know any Dutch. But that sounds like a lot of fun. It sounds like it's probably really loud. What kind of microphones do they record the sound of the cars next to the track? Shotgun mics? I think it takes a lot to realize this. Is there a second part to that? No. Okay. It's going to have to be a microphone that can handle really, really intense sound pressure levels. Those F1s are really, really loud. As you just experienced, I'm sure. So they're just going to have to be microphones with a spec where they can handle a lot of very high sound pressure levels, and you'll have to use a preamplifier that can provide just enough gain to capture the audio without risk of clipping. So some of the field recorders that are designed for recording dialogue sometimes have a tendency to, with some microphones at least, to clip when you're recording really, really loud things. So that's something to be aware of as well. So just test. But yeah, the main thing is going to be the specification, the SPL specification of the microphone, how hot its output signal is, its sensitivity is, and how much you can gain down your input on the recorder. And whether you have a pad on the microphone, that can help too. Although I prefer not to use a pad if you can avoid it. Okay.
I want you to send him a cake.
I just had a birthday. You can send me cake, just no candles. 63 candles is a bit too much. All right, Matt. Well, we'll see what we can do there. It'd be fun to have a birthday party where we could all get together and eat chocolate cherry cake, if you're into that, for those of you that are into that. Maybe we'll look at what we can do at some point in the future. Thanks for the crosstalk clarification. You bet. Alex Knickerbocker's channels might be good for this. I'm not sure what you're specifically... yeah, he specializes in sound for effects industry, so he does that, and he also does a post-mixing for a lot of commercials and I think some narrative films as well. Good resource for sure. Like his channel.
Okay.
Is that everything?
Mm-hmm.
Well, people, that's everything I have prepared for today. Let's just see. Let's give folks a moment here. Actually, let's look at the poll. I want to look at the poll and see where we ended up there. We got 59 votes. 56% say true. 44% say false. Congratulations to everyone that participated in the poll. You are correct. Just depends on the type of cable that you're using, how long it is, and the quality of the cable, so on and so forth. So in any case, thank you for participating in that. Mark said, you just said you avoid pad when possible. Curious why. Those can be implemented in different ways. So you just need to understand the specific way that that particular pad that you're using is implemented. In recorders like the Zoom F-Series, I'm 90% sure that any pads that are used there, if there is such a thing, is done digitally, so it's too late. That is to say, the audio can already be distorted once it comes in, and then they apply the pad, so it's too late for that pad to really be useful in terms of preventing clipping. That's why. If on the microphone it's doing something to the sensitivity of the microphone overall, then that can be just fine. A lot of times, though, they're designed to for optimal performance without the pad. I would just do some testing just to see how it sounds. But there are some bad implementations out there. That's usually going to be on the less expensive gear. But just be aware of that. In some cases, it's implemented in a way that's not very helpful. It doesn't really solve that particular problem. How are the updates to the courses coming along? I'm glad you asked. The Zoom F8 course has been updated, so it now covers the F8, the F8N, and the F8N Pro. We have updated 3 of the segments that were related specifically to that, where we talked about the different bit depth settings that you can use. So the F8 course is updated, and the Mix Pre course is also updated now. We had to update a couple of the segments there, one about audio interface usage and kind of just adapting to how the menus have changed a bit. So those have all been updated. So the F8 course is all updated for the current products and the latest firmware, and the Mix Pre course is also updated for the latest firmware. So all up to date and ready to go, and we're ready to move on to a new course. Okay, do I need an attenuator to connect a Sennheiser XSWD receiver to the mic inputs of a Zoom PodTrack P4? You should not need an attenuator. And Mike has actually tested it, and the answer is no. Yep, so you should not need that. All right, for a 3.5 millimeter to XLR for UWP D27, okay, so that's a Sony receiver, wireless receiver, to a Mix Pre 10.2. It is, to my understanding, I should bridge the tip and ring to pin 2 and connect the sleeve, which is ground, to both pin 1 and 3. Is this correct? I do not know. You'll want to talk to Sony support on that to get clarity on that, but I don't know why you would need to. I would think that adapter cable would be wired specifically to feed correctly without needing to do any bridging. Or are you saying maybe you're asking the XLR, the 3.5 millimeter to XLR adapter that you're looking at buying. How do you make sure that it has these specifications here? I would contact Sony and ask them where to source something like that. Or you could also contact one of the professional sound places like Gotham Sound, True Audio, Production Sound Inc., or Production Sound Corp, I think they're called. Those are based throughout the North America here. If you're in a different locale, there'll be different providers, but that's where I would go to check all of that. I don't know the answer myself. Does Curtis ever do store sales? I love my Curtis Judd ATEM sound course. I don't actually sell at store. Well, not online stores, not retail, brick and mortar. Charles, thanks. I did actually used to work at a vitamin department in a semi-health, a grocery store, basically. Yeah, I was a cashier, and then I moved over into the vitamin department. That was when I was in university, a number of years ago. Haven't done any retail since then. Question for Curtis. Have you ever used Genlock or WordClock, and how often? I have never used it, no. So you're going to find Genlock and WordClock more often in music recording studios when you have to interlock a whole bunch of outboard gear, or Genlock you will find on the bigger budget film sets, especially one very common usage when they were, I don't know if they're doing much of this anymore, but when they were filming for 3D, they would Genlock the two cameras together so that they would be perfectly in sync. And how Genlock differs from timecode in kind of at least general terms is that Genlock, you have an external Genlock device that is the master clock, and it sends a signal to the cameras, or word clock sends a signal to the other devices to say, okay, now record. Okay, now record. So in the case of a camera, it'd be, okay, take a frame, take a frame, take a frame. So they're perfectly in sync. That's the general idea. Whereas with timecode, you have a master clock, and it's just sending a signal to the camera, and the camera records that, and then in post, it interprets that and says, okay, what time did this clip start? And then it just cascades the times according to all of the frames out through the rest of the file, and then it uses that to sync up the audio and the video. So no, I have not used Genlock or word clock.
Charles was asking about discounts on your courses.
Discounts on my courses are my courses are always discounted every single day of the year. Doesn't matter whether it's a holiday or not. We have very low prices all the time. And I've actually, no joke, my business partner, Danny, and lots of other people have advised me that I should raise the prices on all those courses. I haven't, but that's where we're at. Shoji, off-topic question on a mix pre, can you assign the outputs so left output channel can be linear time code and the right channel be audio? I do not believe so, no. No. In fact, I know based on that, just got the mix pre here. I'm just going to double check right now, but my understanding is that you set it to either time code or audio, and you do not get an option to do both. So give me just a second while this is booting up here, and Danny, you can go to the next question.
There you go.
Okay, so outputs. I'll come to this one in just a second. Stereo out mode. You can do audio or linear time code, so you cannot do both. All right. Next question. Can you dunk on a 10-foot rim? I'm a little out of practice. I don't play a lot of basketball lately. There was a time when I could, but presently the answer is no. Just putting that back. Okay, yeah, so Darren, short answer, no. Long answer, there was a time in the past I could. Can you talk about foil, braided, and spiral shields and how they offer different types and amounts of shielding? Audio buff, I think we need to have you come on and talk about that because I don't know the technical differences between them. I know there are different types of shielding, and they have different potential benefits, and perhaps costs as well. So I think how stiff the cable ends up being, how durable the shielding is another thing. I think foil is probably the least durable if I had to guess. I think the braided and spiral will probably be a little bit more durable, but there are probably also trade-offs in terms of the types of interference they can shield from. But lots of good information there. Audio buff, how would you like to come on sometime and teach us about that? That would be fun.
We have quite a conversation going on.
Okay, we don't need to jump into the middle of a conversation. Do you have a detailed course on the MixPre series 2? I do. Yes, the MixPre course covers the MixPre 2 series, and there's an entire section dedicated to the 2 series. So on my courses over at school.learnlightandsound.com, you'll find that in the MixPre course.
I think he's talking about courses.
Are great and worth it. Yes, I'm screaming that. Okay, thanks, Matt.
Okay, hang on. I don't have this.
Put the store link into the chat, Danny. Oh, yeah, it's school.learnlightandsound.com.
Oh, okay.
Yeah, so Danny will put that in there.
School dot
learn
light and sound.
Okay, Danny says that she has a hard stop at the top of the hour, so we've got time for like one, maybe two more questions. What do you got for us? Okay. Well, I think we're in a pretty good spot. Thank you, everybody, for your contributions today. It's great to have the audience contributing so much. We have a lot of smart people here in our little community. Thanks to all of you for joining. I encourage you to get out there and make some great sound this week, and we will talk to you again next week. Take care, everybody.